Thank you, Leo, and thank you to Mitel, Arctic Wolf, and Palo Alto Networks, and honestly to all of the rest of our partners as well. Thank you for bringing us up to this moment that I've been looking forward to for several months. What happened was, I don't know, 6 months ago or so, Justin came to me and said, "We need a speaker that can talk about." He said, "This is how he brought it to me." He said, "You know that movie Armageddon, when Bruce Willis is sitting there and they're trying to figure out the solution to the problem, and he says, 'Aren't you guys from NASA? You got people around that just sit there and think crap up all day long. I need a speaker like that.'" I said, "I got a guy." So, and let me give you a little background before I get to his corporate bio. This guy and his wife Jana, we met, Lee and Jana Johnson, we met about 15 years ago. See, our daughters played softball together. Jordan was a couple years older than Morgan, and so they were varsity, and we thought they were snobs. And they thought we were the quietest people there was because, you know, we weren't supposed to communicate with the varsity players. Turns out nothing could be further from the truth, and Lee and Jana over the years have become fantastic friends of ours. We've done crazy stuff. I had a picture I was going to show, but I'm in Montana, so I better not. It was of Lee standing on the goalpost outside of the practice field at the Grizzlies Stadium, raising the Bison flag in 2015. But I couldn't find it. Well, actually, I found it, but it's been really cool getting to know these guys. When Lee got promoted to this particular position that he has today, they called us all together for a nice dinner, and we were all talking in the background. We thought they were pregnant. We thought they were going to tell us they're having another kid. Turns out he got this promotion. So anyway, I'll read the corporate bio part, because when you're in his position, you have people that sit around and write things up. So Lee Johnson holds the position of engineering manager in the technology development department at John Deere. I think he said last night there's only 8 people in the world that have his job. He's got 7 peers. He and his team lead the advanced engineering and machine architecture projects for planting, small grain seeding, spraying, and nutrient application. Together, they develop new solutions and design initial concepts for machines. In his 28 years with John Deere, Lee has been awarded more than a dozen patents along with multiple Deere Innovation, Collaboration, and Community Service Awards. He earned a bachelor's degree in mechanical engineering from North Dakota State University, originally from Garrison, North Dakota, if any of you know where that is. But then he also earned a systems design and management graduate certificate from Massachusetts Institute of Technology. We're truly honored that he's accepted our invitation to be part of today's event. We're incredibly excited to hear from Lee Johnson about the innovative and technology-driven advancements that John Deere is making. Their commitment to leading the tech revolution to feed the world, or did I have the wrong page? To feed and build a growing world is truly commendable. So with that, I just want you to sit back, relax, enjoy. Let's go. Let me see. We got to go back. My mic on? Can you click on that in the back? So good afternoon, thank you. I'm super excited to be here. Tom, thanks for the introduction. He maybe stole a little bit out of the first couple of slides, but yeah, happy to be here on behalf of John Deere.
We should have a lot of fun in the next, let's say, 40 minutes, just looking at cool stuff that we've worked on that's changing the lives of customers and farmers around the world. So, as Tom said, we've known Tom and Chris and the whole family for quite a few years. Going back to softball, here's the slides that Tom needed for his history of our background. So everything from softball to Bison football games, vacations, and a lot of great chances to make memories. And recently, 5 years ago, we moved to Des Moines, Iowa. So it's great to be back and catch up with Tom and the gang. We also got to know the Fetches and Connors, and so we're excited to meet more of the High Point Networks folks. So, So I know High Point Networks does a lot of work for our dealers. They also have, of course, a strong presence in Fargo, as we do at John Deere Electronics. And so it's great to be here. I'll try to point out some of the technologies that our Fargo teams have helped us with. And I'm sure most of you know for Tom, it's all about the people, right? And for John Deere, it's the same way. We feel that our people are the best asset we've got. And we try to put great people on fantastic projects, give them the resources they need, and let them thrive. So you won't find, and the better thing is if you put together projects that are for people, and you won't find two industries more tied to all of us, the people, than agriculture and construction. We work to make these industries more efficient, more productive, and more sustainable. And we develop cutting-edge technology to make that happen. We say that we try to provide the food, the fuel, the fiber, and the infrastructure for this growing world. So all of you may know John Deere from its green and yellow tractors. Of course, that's the biggest brand identifier that we have. What you may not know is that we've been leading innovation for over 186 years. And that started in 1837 with our founder, John Deere himself, when he invented the first self-scouring steel plow. Now, the plow was used to break the ground across the Midwest in the US when no other tool would do it. And then it cultivated that soil across our most productive regions of the country. In 1918, we replaced horses with engines. And that was with the introduction of the Waterloo Boy, which became the John Deere tractor. In 1947, we developed our first self-propelled combine harvester, which combined 3 labor-intensive tasks of cutting, separating, and cleaning a farmer's crop. And then another example, in 1958, we invented the first all-hydraulic bulldozer. And it had features like a 6-way, fully adjustable front blade that would provide more precision as you're sculpting the land that it's on. So these are some old examples. What about some newer examples? So in 1997, when the computer industry was introducing CD-ROM drives in desktop computers, we were investing in satellite technology. And in 2000, this became the GPS guidance for our vehicles so that they could go through the field and steer themselves and reduce the fatigue from the customer, but also improve the accuracy and precision and avoid overlaps, which wasted seed, fertilizer, and other input costs. The next thing that this did was it allowed farmers to have geospatial data as they're going through the field. So they could tell where the yields were better in their fields. They could also keep track of their inputs like seed and fertilizer rate. And this changed farming forever. Now in 2010, we took all of this data and we brought it to the cloud. And so this allowed farmers to have this data at their fingertips when they needed it, and so they could make these decisions on the fly when they needed to make them. And now, for the decade that we're in, it's become artificial intelligence, making real-time decisions with the information as you're going over the field, and that's what we're going to talk about today. So today, John Deere is a world leader in agriculture, construction and forestry, road building, and even products for your backyard like lawnmowers and recreation vehicles. For more than 100 years, the industry has been focused on equipment, making it larger and more productive. Bigger has always equaled more efficient at either working a field, building a highway, or doing work on a construction site. This is fundamentally changing. Today, the focus is changing from the size of the machine to the technology to make it more precise and intelligent and to improve accuracy. And like I said, reduce these input costs, improve sustainability, and many other benefits. We're striving to improve this with customer value by reducing the input costs improving customer value by reducing the impact on the environment. So focusing on economic value, productivity, and sustainability for the next decade and beyond. And we have an impressive set of machines collecting data. And the data they're collecting is what's going to help us know where can we save, where can we do more with less. This includes over 500,000 John Deere machines that are now covering more than a third of the Earth's land surface. So inside these machines, with many of these products produced in Fargo, North Dakota, we've developed integrated displays, GPS hardware, machine learning, cloud computing, and all of it comes together into the John Deere Operations Center in the customer's home office, where he can make the decisions on what to improve next. So why care about farmers? They make up less than 2% of the US population. Because it's farmers across the world that take on the challenge of producing for all of us. But just importantly, they do it while protecting the most important resource we have, the land. So let me introduce you to some of these important people, of which I've had the honor of getting to know them and call them friends.
My great-grandfather was a freed slave. Not only did he receive his freedom, but the British force gave him 320 acres of land.
My father started as a farmer. He started raising rice in the late 60s. Farming and agriculture and rural way of life was always kind of part of my background.
My dad was a real farmer. Now I've got my son farming with me, and I wouldn't want to farm without him.
Land to me, in my upbringing, is everything. We protect our land.
It's not necessarily a feeling, it's a smell. That smell of the earth and dirt, and it brings back those memories of a child growing up, riding around on the turn roads with my father.
Our living comes from what we produce on the land. So we have to take care of the land so we can be the most productive.
I think all farmers have a personal feeling with their land. I just know that.
I think all humans are connected to the land more than they realize. Whether it's the clothes that you wear or the food that you eat, I mean, you're touching agriculture daily.
No, I enjoy doing things with my hands, enjoy watching things grow, enjoy overcoming a challenge. I love farming. Our sons, they love to farm. So we're just blessed and thankful to do what we love doing.
You have to love something and have it in your soul to want to keep pushing forward and keep waking up every morning and saying, I'm doing it again.
I can tear up real quick talking about this land that we own.
Knowing that we are helping put food on the table for our own families, but also for the families around the world. It's a spectacular feeling.
I think the next generation's going to take care of it and treat it just like we did. Cherish it and make it work for them too. You got to give back to the land what you take out of it, and it's going to take care of you.
The reason we do it should be clear. So before we get into it too far, I'll maybe introduce myself a little more, tell you a little about where I came from and my journey with John Deere, which next June will be 30 years. So I grew up, as Tom said, on a farm near Garrison, North Dakota. It was a beef cattle operation. We grew corn and hay and other crops for the cattle. We also grew durum, barley, other small grains. I learned a lot about farming and machines growing up, and all of this is very valuable to me today. But I can point to a single day that changed my life forever. And it might be a pretty unexpected day. So it was just before Christmas, 1978, and my parents went to Minot to do a little Christmas shopping, and Lego was introducing a new product, their technical set, and it must have been on sale, maybe it was marked wrong. Anyway, my parents went a little overboard. They bought a kit for every kid in our extended family. So a couple weeks later, my brother and I are playing hide and seek in the house, and he tries to climb into a trunk in the upstairs, and he finds these kits of Legos. So you can imagine it didn't take longer than an hour before 8 kits became 1 kit, and they were never going back into those boxes again. But what struck me was this mechanical set of tools. So we were able to build just about anything we wanted to. And so as we're growing up on the farm, we're building what we see. The thought of building a mechanism or a gear set or something that you turn a crank and somewhere else it does something, to me, changed me. And that mechanical aptitude that it brought out led to me standing here today. So that first grade experience with Legos led to a school counselor in the 4th grade who asked, what do you want to be when you grow up? And I said, well, these new computer things, I want to use those to design farm equipment for John Deere. And she thought that was pretty specific and told me good luck, right? Middle of nowhere, North Dakota, that's probably going to happen. But I moved on and went to mechanical engineering at NDSU. And then during my senior year, that same brother said, I saw an ad in the Fargo Forum, John Deere's hiring. You've been talking about this your whole life. It's time for you to apply. And so I did. In April of 94, I interviewed. In May of 94, Jana and I moved to Illinois, and I started my career with John Deere, June 1st of 1994. So one thing that was incredibly important was the first day at work, they paired me with a mentor. His name was Ron Pratt. Now, Ron passed away a few years ago, he had 32 years with the company when I first met him, and he had a long, distinguished career, and one of his most notable contributions was he was the sole inventor of the front-folding planter. Now, if you know planters at all, you know that now, 30 years later, every company has a front-folding planter. The interesting thing was he was not asked to develop a front-folding planter. He was asked to develop a endwise transport planter, a 12-row planter that would be more productive than what we have. Competitors had started coming out with this new endwise transport, and he learned about it, and he said the idea of taking the hitch off and then moving it to the end and taking the wheels and remounting them and adding parts, hours of work to get this thing to go down the road. He said this is a bad idea. There has to be a better way. Well, they told him, during the day, you need to develop the Endwise transport planter. So on nights and weekends, he looked for a different way. So he had this idea of a front-folding planter, and he drew it up. Everything was on drafting boards back then. He brought in drawings, laid them out on a conference room table. Everybody gathered around it. The sketches were similar to the patent photos or the patent diagrams that are on the screen. But everybody said, looks too complicated. I think we need to stick with the Endwise transport. So Ron didn't give up. He made a phone call to Ertl Toy Company. And they invited him up, and he said, I can't tell you what I'm working on, but I need parts. And they let him take a bag out into the factory, and he grabbed row units and wheel modules and markers and planter parts, and he took them home. And what he built was the first prototype of a front fold planter, and it's actually in a display case near the planting engineering center, in the middle of the planting engineering center, along with his old tractor. When he brought this in, set it on a conference room table, simply held the back and pulled the hitch, and it folded. He spent the rest of the day writing patent disclosures with an attorney. There was no more talk of an Endwise transport planter. So together, Ron and this young kid, we started on a new journey. John Deere had made the decision to get serious about the air seeding business that was changing farming across the Dakotas and Canada. Together, we would start this project that would eventually become the 1910 Aircart air seeder. And this was an important growing point for me because my first project was a clean sheet of paper design. And I got to look into the customer problem, talk to customers, develop concepts, build those concepts, test them. And in 4.5 years, Ron and I took a clean sheet of paper all the way to market. And that same air seeding cart is in production today. Last month marked 25 years of that being in production. Ironically, I get to be involved in the project that will replace it, but 25 plus years has been a good run. My next assignment was moving to the planter factory in Moline, Illinois. This is where I got to learn about building these complicated machines at a very high rate of speed, but with very high quality. Often we'll take engineers and rotate them through roles, and it builds a better engineer to know, the needs and have empathy for the other departments and how important they are and what they need, from a good design engineer. So that was an important step. From there, Jana and I and our 2 kids at the time moved to Mannheim, Germany, and we worked on mid-sized tractors. And these computer models that I had used to develop the air seeding cart were now very, very common. And my project in Germany was to help develop the tools and methods of taking 3D models of a product and combine them with 3D models of a factory and plan the factory out in a virtual environment. And so a very fun experience. When we moved back from Germany, I worked at the Deere & Company headquarters in Moline, and I traveled to different units around the world, helping them take the first steps in this new manufacturing planning tool set. From there, I had enough of corporate life. It was time for me to get back to a design role. So I moved to the combine team, part of Global Crop Harvesting, and started working on new combine designs. So a combine is arguably one of the most complex products that John Deere builds. And what's amazing is the hundreds of engineers that are all working together on a single new product, and then to see it come to life for the first time in the shop in just a few short weeks is an unbelievable teamwork, evidence of teamwork. And so whether it was testing combines in Texas or Oklahoma as part of the wheat harvest, or in eastern England, where they have a growing season that's over 11 months long and harvest on some of the steepest hills in the world. Being part of the Combine team was definitely some of my favorite parts to my career. So for our next adventure, we moved to Fargo. To be closer to home, we wanted to try grandparents being around. We were about to have our third child, and so I worked on developing electronics, including electronic displays, hybrid vehicle solutions. I helped design a family of vehicle controllers that are used today on many of our products. I even designed an engine controller that used diesel fuel to cool the controller when it was mounted near the engine in a very hot environment. And so if you've never stopped to see what John Deere Electronics does in Fargo, it's definitely worth a visit. So now after 12 years in Fargo and 24 years into my career, we got the opportunity to make our next big move to Des Moines, Iowa. And so, as Tom said, I lead the vehicle architecture team for John Deere Crop Care. And so our agriculture, our large production and precision agriculture division, it's split into three groups. We have large tractors, we have crop harvesting, and then we have crop care, which is everything else. So tillage, planting, air seeding, spraying, nutrient applicating. And so my team includes the architects and technology development leads for each of those areas. And each of those teams start with a new opportunity. This might be a customer pain point or a new idea of how to do something. And they investigate the problem, develop the first concepts, build concept machines, prove that it's possible, and then they shape it into a great project that is a good solution for the customer, but also is going to be a great product for John Deere. And then we wrap it up into a project that gets launched into one of our engineering teams that will take it to market and make it a reality. So we're going to see a lot of cool tech today and cool projects, and a lot of those are in the crop care space. So first, let's talk about a few challenges our customers face. So these pain points that turn into opportunities. So challenging weather is a huge issue. Changing markets that force them to scrutinize their inputs and try to maximize their yields. And then labor shortages. Virtually everywhere in the world that farming is done, a farmer is worrying about enough skilled labor to keep his operation going. The big challenge, feeding this growing population. So over the next 25 years, we'll go from 8 billion people to 10 billion people. And as this population grows and diets change around the world, there's going to be a need for more than 50% more food. You may not know that over 2 billion people last year didn't have a secure source of food. So meanwhile, farmland is reducing. Cities are expanding. Many other things are taking land away. So reducing farmable acres while increasing production, the math doesn't work unless we step in and try to solve the equation. So in the past, farmers grew more with more. Bigger machines, more horsepower, more seeds, more fertilizer, and that's what's going to change, and we're going to change it. Technology is going to help farmers create more with less inputs, less fertilizer, less herbicides, less labor, less fuel, and less impact on the environment. These are some exciting projects to be a part of. So we had a slogan at CES this year: real purpose, real technology, real impact. Now CES is the Consumer Electronics Show in Las Vegas. It's the largest technology show in the world. And the last few years, John Deere has brought their technology, and the people attending the show and even the other presenters have been blown away. What makes it more impressive is we aren't bringing concept vehicles to the show. We're bringing examples of tech that we've brought to the market that's in customers' hands and is already having an impact on them today. So I want to take you on a tour of some of these projects. They'll help you understand that John Deere is not just a manufacturing company. We've quickly become the world's leading developer of robotics and artificial intelligence. We use computer vision, advanced sensing, and compute, and we're transforming this industry, and we think it's going to have a bigger impact than even the tractor. So nearly 2 years ago at CES, we introduced the first commercially available, fully autonomous tractor. It features sensors, computer vision, machine learning, and many other technologies. These are in customers' hands today. Today we'll talk about this tech and other advancements that this has introduced. In a few minutes, I'll dive a little more into the vision and machine learning technology that enables the autonomous tractor, but first, I'd like you to hear and see one of these at an operating farm near us.
When you start out in the spring, you work the soil, and it just smells so fresh. When you till it up, and it's just the greatest smell. When I started farming, there basically was no technology. Every tractor was driven manually, everything was done manually. You'd be planting, you had to follow a line. If the sun was wrong, you would lose the line. Darkness, you couldn't see your marks. Moisture, you couldn't see your mark. Then you'd get squiggly rows. My name is Doug Nems. I'm a farmer from Blue Earth, Minnesota. I'm a fourth-generation farmer, and I raise approximately 2,000 acres of corn and soybeans. I really never thought I would see an autonomous tractor in my farming career. For me, it was really exciting the first time I got to take the autonomous tractor to the field, swipe my phone, watch the tractor start with no one in the cab, start doing tillage, come to the end of the field, turn on the end, do the tillage just as well as I can do myself with no one in the cab. I can pull up the app, I can monitor the tractor, see how much of the field it's gotten tilled, I can check the fuel level, I can check the app to see how much of the field is left. If there was something in the field that it wasn't sure about, the tractor will stop and alert me. Is this something I can go around? Do I need to go out and remove an object from the field? The app gives me all this information so I can monitor everything very closely. On farms, labor is always a challenge. We need labor for lots and lots of hours for short periods of time. The auto steer and technology has helped reduce our labor load, which makes my life a lot easier. Autonomy will help because we will be able to put a tractor out in the field and let it run for 24 hours a day because it's not manned. But it also helps us with the weather because we can run so hard when soil conditions are fit. The thing that excites me the most about autonomy is not be locked in a tractor cab all day. It will just allow me to run my business better because I can just pay closer attention to other tasks. Now we'll be doing the jobs that we always wanted to get done but never had time to because we were in the cab all the time. Farmers are fairly traditional, but I have a feeling that once they try it, they will become very accepting of it. I think the tractor can do a better job than I can do. Autonomy, it's going to be a life changer for me.
Pretty cool stuff, and that's just tillage. So let's talk about planting. Now, planting is one of the most important steps of the whole growing process. We like to say that during planting, you set your maximum potential for the year. If you don't do planting right, you can't fertilize your way out of it, you can't spray your way out of it, and you sure can't harvest your way out of it. This needs to be done right. So I'm going to talk a little bit more about our ExactEmerge product. So with ExactEmerge, we introduced it in 2015, and we doubled the speed of planting from 5 miles per hour to 10. For corn, that's putting down 30 seeds per second. And we do that with a brush belt that holds every seed and then drops it at exactly the speed of the ground so that it can't roll. And so as these are not dropping, they're being held in place, a sensor can pick up exactly the location of every one of those seeds and keep control of it to the point where it drops. And so the speed of the belt is matching ground speed. The speed of this singulation bowl is what's telling the machine the exact population of seeds that the customer wants to put as it's crossing the field. These prescriptions drive how fast and the seeds get put into the brush. And vacuum then singulates those from the pool of seeds that's in the meter. So a little bit of background about ExactEmerge, but it's this technology that we're going to build on for the next innovation that we've brought out. So during planting, a planter can also put down fertilizer. And farmers often put down starter fertilizer on the seed. After corn germinates, the seed creates some roots. And the first roots are these seminal roots that only go about an inch away from the seed, and they're trying to find phosphorus and turn phosphorus into energy so it can build big roots that go look for moisture and nitrogen. The thing is, this phosphorus doesn't move in the soil with moisture like nitrogen does. If it's not mechanically in the right location, the seed never uses it. So you need phosphorus within an inch of the seed, but the seeds are 6 inches apart, and current technology only allows us to spray the entire trench. So there's a 4-inch gap between these seeds that phosphorus is only going to get to weeds. And so it's not going to help the plant at all. So with ExactEmerge, we're using this brush belt technology and that accuracy to combine with our technology from our sprayers, and it allows us to spray the fertilizer only on each seed. Now keep in mind, this is 30 seeds per second per row, and the seeds are not always the same distance apart because the customer has different populations in the low spots and the high spots, and if the machine turns around a corner, every row unit on the machine has to go at a different speed to put the seeds at the right distance. And so this allows us to save 2/3 of our starter fertilizer. Now, there's 90 million acres of corn grown in the US each year. They put down 140 million gallons of starter fertilizer. If we save 60% of that, that's 93 million gallons saved, or a value of over $650 million a year. That's a huge impact, and it doesn't hurt our environment either to put less into the soil that's not needed, right? So this is a great example of grow more with less. So the next few technologies are going to look at a specific category of technology, vision. Over the past 10 years, John Deere has put an enormous amount of effort into developing vision and vision processing technology. Back in 2015, we launched our very first vision product. It was a stereo vision camera and a geometric model that would detect the rectangular shape of a truck. And as a forage harvester would go through the field, the vision system would not only detect where to adjust the spout to fill, but you can see the bar chart on the side, projected on the side of the truck, that shows how full the truck is in each location. And so this will automatically fill the truck, reducing spillage and making sure every truckload has the full capacity that it was made to carry. In 2016, we introduced a monocular camera on our sprayers that would look at the rows of the crop and help our GPS system to make sure it's never driving over the plants we're trying to protect. Then in 2018, we launched our first product with CVML. And it improved the quality of how we separate crop inside of a combine. Now, CVML is computer vision and machine learning. And what it involves is taking this visual data and creating a mathematical model. And the mathematical model is a neural network of logic similar to how your brain works. And so we placed cameras at specific places in the machine where it could look at the job that was being done, and we feed it data of what's good and what's bad and what adjustments to make if you see these different situations, and the machine starts to adjust itself. The unique thing is that it continues to get better and better the more data sets that it comes across and solves. And then last year, we unveiled our autonomous tractor. Oh, let me see here. You might need to cancel and re-present. I don't know if this is working quite right. Sorry about that. Then last year, our autonomous tractor. It uses CVML also with 6 pairs of stereo cameras to detect and identify objects. Now, full autonomy forced us to rethink how we train these models. Typically, you train them by giving them data sets, right? And train the cameras to identify things that are good and bad. For instance, you could train the cameras to identify a person, an animal, a rock, a rolling bag, a tumbleweed, and on and on. The challenge is that there are millions of combinations of things that these cameras will see in front of a tractor. But there's relatively very few situations that are actually something that we care about. And so we turned the equation on its head, and we made the model identify the 3 things that a tractor really sees, which is the soil, the tree and building lines, and the sky. And we trained it that if you see anything that's not soil, tree line, or sky, stop. It's the safest thing to do. And it was the easiest way for us to train this model on what to worry about. The cool thing is that the machine learning will improve it as we teach it about these objects that it's seeing. It will continue to get smarter and smarter every year. So the next one, technology, nobody expected. Since the first sprayer was introduced, farmers have sprayed the entire field, even though weeds are only in specific areas of the field. Similar to when you mow your grass and you only see a weed here and there. So in March of last year, we introduced a product we call See and Spray Ultimate. It uses computer vision and machine learning to see and identify every leaf in the field and sprays herbicide only on the small areas that have a weed. This is important because a weed robs the plant of nutrients, of moisture, of sunlight, and this has allowed us to save 2/3 of the herbicides that are put down on a field. Now keep in mind, this is detecting every leaf larger than a kernel of corn, and it's traveling at 18 feet per second. It's an incredible technology. Last year, customers started receiving their machines and putting them to use. This is not a futuristic technology. We have these being shipped to customers as we speak. So on the right side of the boom on the screen, you can see the cameras that are mounted above this custom carbon fiber boom. Now, there's 36 cameras that capture 1.2 billion pixels at a time. And the machine learning model identifies every leaf, again, in milliseconds as it's traveling 18 feet per second. If you wanted to match this with human eye and brain technology, it would take over 6,000 people. I've been in the field where we've tested these and we use blue dye to show where it's actually sprayed. And there's times where there'll be 6 or 7 of us standing around a small blue spot trying to find the weed. And then finally, somebody gets down on their hands and knees and says, I found it. It's this tiny little leaf. And it was going through the field at spraying speed. And this is doing this over uneven terrain with dust and sunlight and shadows. It's an incredible technology. But to do the calculations, we had to work on a custom video processing module with our team in Fargo. It has the most powerful NVIDIA gaming processors that are available, and there's 10 of them across the boom. These process 4 gigabytes of data per second. And it's doing this in harsh conditions, in temperatures, maybe 100 degrees Fahrenheit. And we do this with controllers that are only air-cooled. So let's go to the farm and let's see.
The sprayer is one of the most important tools. A lot of people don't realize that weed pressure and weed control is an extreme problem we deal with. I would compare it to a bully. A weed is a bully to a plant. I want to eliminate all bullies from my farm. If I've got 2 billion plants, I've got 20 trillion weeds. My initial reaction when I saw See & Spray technology was it's a game changer that could potentially disrupt an entire market. Because I only want to apply the product that I'm trying to apply to a field where it needs to be. It detects a weed versus my plant. That allows me to save money and save time. The first time I operated the See & Spray Ultimate was extremely exciting. I was sitting on that machine and it's only spraying where it needs to spray. You'd be amazed at what it detects. It could be the smallest twig of grass that it will detect and spray. With that See & Spray Ultimate, we're able to get some weed pressure maps. We're able to get some data from that application that I can use in the future to make a decision. Do I need to target that area a little bit more in some other practices to minimize that problem? I've seen anywhere from 70% to 50% cost savings with the See & Spray Ultimate. If you can minimize herbicides that you use, it's going to be better for everyone. And with See & Spray Ultimate, you can do that with the technology to get the job done and to get it right.
Human vision, though, is really sophisticated. The eyes, our eyes working with the visual cortex part of our brain is probably one of the most complex systems in the universe. But we've been able to develop the vision technology from cameras and this compute to now be superhuman. And we're adding that technology in places where customers can't see everything as it's happening, and we allow them to make those decisions on the fly. Farming is a very visual operation, and the opportunities that we'll uncover with vision technology, we've just begun. So at John Deere, we say we run so life can leap forward. It's a really good mission, and it's a really good reason to work hard. Each of these projects that we talked about today starts with a small team focused on that opportunity and solving this customer problem. The technology is cool, but we really don't do it to create cool technology. That's almost a byproduct of solving a problem. So we don't develop technology just for technology's sake. So thank you for allowing me to talk about what I'm super passionate about. It's been great to meet you. I will be around for the afternoon. Happy to try to answer some of your questions if you've got them. So.